Hey everyone. I'm Marten, and I'm going to talk today about our latest project that we've been working on for the last 2.5 years at About You in the BI team. And the project is called Cube, and how you could also call it is how we abused PHP and Laravel to do big data. Or you could also say the story of how we created our Frankenbaby. So I'm just going to give you a short introduction of About You, and we are an e-commerce fashion company that is basically just selling fashion over the internet. We launched in May 2014, and we are currently around a bit above 600 employees there. And out of those 600, we are around about 200 tech employees. And we just recently became a unicorn, meaning we're worth around 1 billion now. So, short intro to me. I'm Marten Westphal, and I've been a software engineer as part of the BI team at About You for the last 2.5 years now. And I started there as a working student, working on Cube, and also did my bachelor thesis on it. And we've been working as a team on Cube for the last 2.5 years, and the kickoff of the project was by Pascal Landau, who planned the entire thing, and then I joined in as a working student. And mid of 2016, Benny took over for Pascal as the tech lead, and I joined him on October as a full-time developer. So here you can see us on an everyday working on Cube. And I just wanted to get a short impression of what you think about the idea of PHP and Laravel to use to do data consolidation. So I would like everybody to stand up. No, really? Just stand up. Okay, and now everybody stay standing who thinks that using PHP and Laravel to do data consolidation can stand, and everybody else can sit down. Confusing? Did I confuse somebody? So if you think doing data consolidation with PHP and Laravel, you're supposed to stand now, everybody else can sit down. Okay, that's actually more than I thought. Who do you think, what do you think? Or now everybody sit down who thinks there is a better way to do data consolidation except for using PHP and Laravel. Okay, that looks better. Okay, so same thing that I thought when I came into the project in 2016, and I came from a C world doing rendering pipelines and virtual reality calculations in my bachelor, and so it was quite a surprise to me when I came into the company and I heard we are doing data consolidation with PHP. And I still kept on going. I was there in the project for half a year, and then I wrote my bachelor thesis on it. And during my vocal exam, I was standing in this room having a presentation similar to this one. And my professor and 2 other professors were sitting there. And at the end of the presentation, my professor was sitting there, and we had this Q&A session, and he was like, well, I really have just one question, Mr. Westphal. Why PHP? And I mean, that's a valid question. Why would you use PHP for big data, or data consolidation for that matter? Before I get into that, I just want to show you some of the magic that we've been building. And I'm just going to quickly talk about what Cube is. So, that's Cube. So Cube is a DAG, a directed acyclical graph, able to consolidate data in a dependent graph, and you have these smaller nodes that can do a bunch of things. And we have dependencies on each of those nodes that are related to the prior ones, and you can also do a bunch of other events that trigger certain nodes. You can do timings on those nodes, and then those nodes are actually able to read from a variety of databases and also files and BigQuery at the moment, and then do a variety of tasks on them. So for example, we can just do simple ETL tasks, so just extract, transform, and load it into another database. We can do aggregations. Actually, that's just on the database and the Google BigQuery. And we are actually also able to do a really complex consolidation task based on PHP on an ORM approach. And then we are also able to write, of course, to all those targets. So there's one downside with this. If you build something from the ground up, you have no tooling. So there's nothing around it. You have no monitoring. You have no handling of errors, nothing. And that results in something that I would call quite ugly tooling. Actually, it's not that bad. Like the left one there, that's something we built just to have something cool on our screens while it's running. But it also has like really little information except for which node is running at the moment. Okay, so moving on. So let's get back to the question. You might ask yourself, Martin, why PHP? So, I mean, why PHP? Why the moon? Kennedy said, we choose to go to the moon and do the other things in this decade, not because they are easy, but because they are hard. And that's why we did that. No, just kidding. So the actual reason for doing something like that is a concept that our entire company is built up on. And it's called MOVE, and it has 3 core principles. And the first one is striving for excellence, meaning everybody is really trying to do the best in their job. Like you can really focus on your field of expertise and do the best you can in that field. And then we have clarity is king, meaning we have a lot of open communication channels, we have a lot of retros, but the most important part is open structure, meaning you can basically switch due to a transparent tech stack in our company from every department into any other department without having to learn a new technology. So we have PHP and Laravel and Lumen in all of our departments in the company, and our entire shop is running on that. And so basically, when you have a lot of manpower needed on a certain project, you can just say, okay, we can take a few developers from that team and then have them support the other team that has a lot of pressure at the moment. And that's actually the reason why we did that. So there's no real technical reason for that. So I'm going to talk about the project now and how this project evolved over the last 2.5 years. And just to get a better an impression of how we evolved, I defined 5 milestones, and the first one is the plan. What we were initially thinking, what the project should be, how it should evolve, and what it should be able to do. Then I just picked my bachelor thesis because that was like a cut for me back then. And then we have in mid of 2000 or beginning of 2017, we had a big refactoring because the project just got way too big, and we had to put a lot of work into making it look nice again and have it have a really simple approach again. And then we will go to the present, what we can currently do, what were the last things we've been doing, and then we will take a short look into the future. So, we planned in the beginning of 2016, we planned that we wanted to have a DAG that is able to do a variety of tasks. Basically doing ETL jobs on each of those nodes, and then have it really simply and easily extendable, and also have a real easily ORM approach, meaning that you're actually able to do data consolidation and put the data into relation just by using objects in PHP. So that was the approach that we had because we wanted to have everybody being able to just get into the team and just help us. But on the other hand, we also wanted to have this way more complex processing because at a certain point, if you do data consolidation simply based on SQL queries, after having like 10 joins or something, you're actually having quite a performance issue if you're doing a lot of joins. And then we also had a test-driven approach, which was because we had an old system running on a Hadoop cluster using Python and SQL queries. And the problem with that was that we had a lot of snowflakes. It was really cost inefficient, and yeah, it was just old and nobody really understood it anymore. So we thought, okay, we built something new, but we want to make sure that we have that data saved and we do the consolidations right in the new project. And all that based on Laravel capabilities. Sounds easy. So, of course, there were some bugs and some problems that we were facing in that time. And I'm going to talk to you about which those problems were. But first, I thought maybe somebody has an idea of which problems we ran into. Anybody? Come on. You all said it's not a good idea. Which problems could you face? Yeah?
Performance problems.
Yeah, obviously. Yeah. Performance problems, yeah. Somebody else, anything? Sorry? Yeah, I would say that's like going into about the same direction. We actually went into the project and thought, okay, of course there will be some problems, but our expectations were mostly quite good. But as you all know, as software developers, the reality doesn't always look like the expectations do. And yeah, as you already thought of, we had a runtime problem in the beginning. So it turns out PHP processes are actually not meant to run for hours. So yeah, PHP is usually supposed to take a request, then compute that, and then put it back out. I mean, I have no idea what the usual runtime is on that max, but I would say a few minutes, maybe. And then that's like the request should already be thrown away. But we had a problem that we were actually running PHP processes for hours, and at some point the PHP process got really, really slow. Like in the beginning it was actually quite good, performance-wise, but it just turned out that at some point, mostly we think to memory issues that the garbage collector is doing a bad job. We had these performance issues at a certain point, and yeah, that was a really big problem for us, and we tried to solve it, tried to tweak PHP back then. There was still PHP 5.6, and we tried to tweak it everywhere, but it didn't work out. And then we said, okay, let's just avoid this problem and just chunk our data into so small pieces that we can just basically run those smaller pieces on every worker we have possibly there, and then just avoid the problem that way by just saying, okay, we just avoid run times of 5 or 10 minutes max. So yeah, you could say that's not a pretty solution, but it does work. And that's a real picture, by the way. I think that's quite amazing. You see that? Yeah, last About You summer party. No. Okay, so the next problem we faced was no jobs overhead. So resulting from our previous solution, we had the problem that if you chunk your jobs too small, the pieces of data, you have to load the entire Laravel framework and everything that is surrounding that every time. And that's not a problem if you just do simple requests, like a few 10,000s or something. But if you actually do that like millions of times, that actually becomes a problem performance-wise. So we had to figure out a way to load the data and have actually a bit more intelligent approach to the chunking, and also have the related data that was related to every row also being chunked, because we were chunking on primary keys. So saying, okay, we have, I don't know, 100,000 primary keys, and we just say we take parts of 10,000 or 5,000, and then we just consolidate these 5,000 chunks. That actually turned out that we have primary keys that have a lot of related data, and we have some primary keys that have basically no related data, meaning we were actually running on some jobs really, really long, and on some jobs we were running really, really short. And we had to solve that by evaluating before starting a job how much related data is going to be loaded, and then we introduced an arbitrary primary key to each of those tables and said, okay, this piece of data with this relation has an arbitrary primary key that would then load via that arbitrary primary key. Yeah, so that was that. And the next thing we had was bad load performance. So I'm not sure if that's ever was a problem to anybody, but if you write to a database and you do that with tens of gigs of data, that is actually quite slow. And especially, I'm not sure if it's a PHP problem, but I think it's an SQL problem. But yeah, we had that problem, so our write speeds were really, really bad. And we actually fixed that by load data any file. So we exported our data into chunked CSVs and then just import those CSVs into our database. And we were back in our happy place. Everything was pretty. And we were, at the time, in the end of 2016, and I was doing a bachelor thesis on it. And we had fully implemented any function that we planned in the beginning of 2016. We transported all our consolidations that we were previously doing on the Hadoop system onto our new Cube system, even though we were quite a bit slower. So Hadoop was running around half an hour, or yeah, basically half an hour, and the new Cube system was running 4 hours, which is okay if you consider that it was running on PHP. And what was good though with the new system is we were saving a lot of money, because the new system was actually like 1/8 of the cost of the previous Hadoop system. And we had this easily extendability of the system, and we were able to manage it really easily and had no more snowflakes. So, moving on, everything is nice, but we were running into more problems. So the first problem was not really a problem with PHP, but a versatility problem. So our head of BI came up and said, hey, we can do so much cool stuff with this project, let's do even more. And yeah, we thought about it, and we introduced a new layer onto Cube called Tesseract. If you know what a Tesseract is, that's a Tesseract. It's a 4-dimensional cube. Yeah. So yeah, we built this extra layer on top of it, and the problem with that was that we lost the simplicity of the project and was not easily extendable anymore. And we actually had to do a big refactoring after this step to solve that problem afterwards. And then we also ran into something that we saw coming, but it still was a problem back then because we didn't realize that it happened already. And the problem is that we have some of our processes in the business intelligence team still running on Python, because machine learning is really not, I'm not sure, but maybe we do PHP machine learning at some point, but at the moment we're doing it with Python. So we had this Python scripts training a model, and we also depended on that data that was from the trained models being consolidated. And there was a problem that we said, okay, we just start the machine learning algorithms at a certain time, because then we expect our data to be done. And then after that, we will start our consolidation processes again that depend on that, and everything works out, right? No. So yeah, we had the problem that we thought maybe we will actually realize when that goes wrong, and we didn't, because the Python scripts actually just used not fully consolidated data, meaning the models were wrong, we fucked up all our trained models, and the data that was then predicted by that model was also just not complete, and we were doing all our consolidation on the data that was not completely loaded into the database, leading to a lot of bad data and a lot of stress for 2 weeks. So yeah, we had to build a wrapper around this Python scripts that would actually just give us the ability for the Python script to ask our system, hey, are the data nodes done yet that I want to access? And then we also had a wrapper, and that wrapper, an API that would allow us to contact the Python script saying, hey, are you done yet? And that was the problem that we solved then. So solving the problem of Cube and Tesseract. As I said, we had a big refactoring. It was 2 months of just refactoring these 2 big blocks of frameworks into one again. So we had this easily extendability again. And yeah, as I said, we're merging the Cube and the Tesseract's jobs into one, that we had a generic abstract task that could then easily be extended either into a simple ETL job or doing this really complex stuff that we had in the Tesseract jobs, which are basically able to then also do a DAG in a DAG. And if you really push that, you could actually build a recursive DAG in those Tesseract tasks in the DAG of Cube itself. And also at that time, that was more happening on the side. We went stateless. So before that, we had the problem that if a package of a bigger node would fail, we had no way of knowing which of the data was written by that package. And so we had to restart the entire node, which is a bit problematic if you had a node that's running for 1.5 hours, and you would lose quite a lot of time with that. But yeah, that really helped us because every once in a while we had a network problem or something, or the database was not available for a few minutes, and yeah, that really helped. So we are back in our happy place. And we thought, but there were more problems to come. So the problem really after that was that our company was growing so fast that we had a lot more data than we anticipated. And meaning we had to optimize every single piece of Laravel to do what we wanted in the efficient time that we needed it to. And to do that, I actually have, live coding is always great. Whoops. Okay, yeah, we get to that. So I actually brought you a bit of a, there we go. So I brought you a bit of a performance test here. And while that's running, I will show you what it does. Oops. So this is the performance test. Oh, this is badly readable. Okay, but basically what it does is it creates like 1 million objects. Where am I? There. I'm just going to read there. So basically what we are doing up here, we're just creating 1 million objects that have just some random data, and then we shuffle them. And then we have those 2 collections, the one that we wrote and the one that we get from Laravel. And then we have just a creation method that is doing that on the random data. And then we have a variety of functions that is called on each of those collections. And yeah, so you can see here we do a flatten, then we do a group by with a key, and then we do a sort by with a callback, and we do a sort by with a key, and we calculate the median numbers and everything. And let's say how the performance test is going. So you can see here that the flattening and everything is working already a bit faster. So that's like, yeah, maybe 8 times the speed of our collections. And this is actually going to take so long that I have to get back to my presentation here, because you will see in a second what I mean. Actually, don't try to allocate more space on your virtual machine than you have. It's a really bad idea. It completely crashes the entire system. Okay, so I provide, I already did this yesterday evening with some smaller numbers. So we have 10,000, and you can already see here that the flattening, that's the Laravel, and that's our own. And you can already see, is that Laravel? Yeah, so that's the Laravel, and that's our own. And you can already see that the flattening method, but everything else, just like we are already here on the plug, we are actually a bit slower on 10,000 objects. And so I pushed it a bit, and I thought, okay, let's try to figure out where we go with 100,000 objects. And you can already see there's quite a difference there. So, but overall, it still looks fine. Like we have max objects that is quite slow. But I thought, I push it a bit further. So we have 1 million objects now. And now you can see, OK, here we have this. And you can see why this is taking so long. So we will actually have to wait, I think, until the end of the presentation here to get that done. And I think the biggest one is this one, which really surprised me. Like, if you look at the code, if you're interested in the code, you can just come to our booth afterwards. But I don't want to go over the entire code here. But if you look at the code, it's actually like we are not doing a lot different. This is almost the same code. We are just avoiding a lot of calls on like doing deeper calls and doing recursive calls. So we are just having a for each loop instead of just doing recursive calls, which actually is nicer to look at. Like the Laravel collections look nicer code-wise, but we are just pushing performance. So let's take a short look if it's done yet. OK, I can't get out of here. OK, never mind. We will look at it at the end of the presentation. So yeah, that was the collection performance. And then also we had a problem with Eloquent, which, I mean, I like Eloquent. When I got into the project, I was amazed by not having to do SQL queries anymore and just being able to query that really easily over Eloquent. But also Eloquent is really slow, really slow. And yeah, so we built a new generic query builder that is actually also around 10 to 20 times faster than the Eloquent. And we also have built a new ORM on top of that that is also a lot faster. And also, if you want to see that code and you want to go over that or you want to know something on that, just get back to me on our stand and talk to me about it. So, we're here today, and the last thing we added was actual big data capabilities. Sounds wrong, but we solved that by simply going into the cloud, and we're able to export all our data into Google BigQuery, and where we already have our tracking data and everything. So we're able to do the actual big data consolidation in Google BigQuery just by exporting our stuff there, and have this generic query builder that I just mentioned is also able to compile to BigQuery SQL. So let's think about what could happen in the future. We just don't know yet. We will see what problems we run into and then, yeah, approach them. But what we are already thinking about doing in the future is having the ability of a theoretical cluster. So if you think about it, we're already stateless and we already have a decentralized system. All our data and our processes are in databases already. So basically, it shouldn't be hard. And to be fair, I've been thinking about that since my bachelor thesis. But it shouldn't be hard to go into a cluster and have a master-slave principle and do a lot more with this project. And then something that's really, really something I want to have in this project is automatic incremental data updates. So right now, the system is running every morning, doing all the data. Like we literally consolidate every piece of data that we have in our system every day. And you can see why that's a problem. And at some point, we are growing so fast at the moment, like we grow every week by the amount of data we started off in 2016 today. And you can see why that's a problem at some point. Like we can push the performance as far as we want, but if we consolidate data that is not changing, it's just a pain, and we shouldn't do it. So, yeah, summing up, it was a lot of pain. And even though it looked at first sight really horrible, and we had a lot of problems like putting together, piecing the project together, doing like taking parts out of PHP and Laravel, putting other things on there, the whole thing actually turned out to be quite cool. And I'm really proud of the project. To summarize the whole thing, is it possible to build a potent big data, because we're exporting those things to Google BigQuery at the moment? Is it possible to do a big data consolidation framework using PHP and Laravel? Yep. Would I recommend it? Okay, so that really depends on a few things. So if you have the resources to do a project like that, and you have this basic idea of a transparent tech stack, and in general, I would just say you have to evaluate what you want to do, what you can do, and if you go for if you're a small company with like 10 employees and there's one guy doing the BI, don't invest the 2.5 years into doing something like that. But in general, if you have something that is really tailored to you, to your needs in the company, then yeah, sure. If you want to do it. And that leaves me to thank my co-workers on this project, Pascal and Benny. I learned a lot from those two, and to leave you with something, that's something that I just said. Don't let anybody ever tell you it doesn't make sense to do something in that way, because there is no single solution that fits all purposes. And at least you're going to learn a lot during the process. And even if you fail, you will fail learning a lot. Thank you.